In this video lecture, we're going to discuss entropy, microstates, and probability, and we're going to describe probabilistically why high entropy states are more likely, why particles are going to be distributed in more random fashion rather than being distributed in a more organized manner. So, why things would tend to go towards disorder rather than towards order. So, we're going to use probability to describe why things tend to gain disorder. So I have this container over here, and this container has two sides. One is the left hand side and the other one is the right hand side, and there are 8 possible positions where particles could exist. So I've simplified my container. There are only 8 possible positions in the container. In reality, there are going to be infinite possible positions where particles could exist, but in our container you just have a total of 8 different possible positions. And the container has two sides. One is the left hand side and the other one is a right hand side. And I have 4 particles. All are different colored. One is yellow, the other one is green, blue, and then I have a red particle. And I'm going to try and place these particles in this container, and I'm going to see the different arrangements that I can come up with. The different arrangements are called microstates. So I've drawn these microstates over here, and these microstates show all the possible arrangements of these particles. So I have this first microstate over here where all the 4 particles are on the left hand side. So there's only one microstate where all 4 particles are on the left hand side. So that's only one event. Then I'm going to try and place the particles 3 on the left hand side and 1 on the right hand side, and I'm going to come up with how many number of microstates can I come up with. So there are 3 particles on one side, 1 particle on the right hand side. So there are 4 possible arrangements in which particles could exist in such a manner. So there are a total of 4 possible arrangements. The third microstate is that I want 2 particles on one side and 2 particles on the other side, and if I make the arrangements, there are 6 possible microstates where these particles could arrange in that manner. 2 particles on one side and 2 particles on the other side. So I have 6 possible arrangements in which the particles could be equally divided between the 2 sides. Over here I have 3 particles on the right hand side and 1 particle on the left hand side, and the total number of microstates that I could come up with, there are a total of 4 microstates. So this arrangement, 3 on one side and 1 on the other side, there are 4 possible arrangements. And then I can have 4 particles on the right hand side. So there's only one possible arrangement, one possible microstate for that. So these are the total number of microstates that the particles could exist in. So now I'm going to calculate probabilities of having each microstate. So starting with the first one, 4 particles on the left hand side, so there's only one possibility, and the total number of events that I have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So out of 16 possibilities, there is a chance of only one out of 16 could have a possible arrangement like the one shown over here. Then I would have this probability. I'm going to try and figure out the probability of having 3 particles on one side and 1 particle on the other side. So the total number of possibilities for this is 4 out of 16. Then I'm going to try and calculate the probability of having 2 particles on either side, 2 particles on the left hand side and 2 particles on the right hand side, and the total number of events is 6. So based on the probability, I would have 16 events in total, and 6 out of those 16 events are going to give me that result. Then I have the third possibility of having 1 particle on the left hand side and 3 particles on the right hand side, and again there are 4 events that would produce that. So it's 4 out of 16. And then I have this last option where I have 4 particles on the right hand side, and the number of events is just 1, so that's 1 out of 16. Now if you look at the probability of the events, then you would notice that the highest probability of the particles arrangement is this one, 6 out of 16. So the highest probability goes to the particles with the most disorderly arrangement, where the particles are divided equally between the 2 sides. So probabilistically, the arrangement of the particles would tend towards the more disordered side. They're going to have a higher probability, and the more ordered arrangement is going to have a very, very low probability. So this is why, because the particles, this is the reason why particles have a higher probability of being arranged in a more disorderly manner. So if you keep on increasing the number of particles, the probability of having the most disordered arrangement would be the highest. So you can do this with 8 particles, you can increase the number of positions, so you can keep on doing that. The number of microstates would keep on increasing, but the state in which the particles are most disorderly, that state is going to have the highest probability, and this is shown in this example over here. This state over here has the highest probability, and the state with the most ordered arrangement has the lowest probability. Now to sum this up, low entropy states, the one that is shown over here, has a very low probability, whereas the high entropy state, where the particles are more distributed, they have a very high probability. So this is why things would go from low entropy and they tend to go towards high entropy. So things like to gain disorder, or they like to gain entropy. So this is the example that we did previously as well. So this state, achieving this state, has a very high probability compared to achieving this state over here. So things would tend to, these particles in this glass jar, they would tend to move towards high entropy, because having high entropy also has a very high probability. And as the number of particles keep on increasing, the probability of attaining the high entropy state becomes greater and greater, and the probability of attaining the low entropy state becomes lesser and lesser. So as the number of particles and as the number of possible positions keep on increasing, the low entropy state, the probability of achieving the low entropy state becomes lesser and lesser, and the probability of achieving the high entropy state becomes greater and greater.